Welcome back, everyone, to the eCoreAcademy e-learning platform. My name is AJay Raj, back with yet another Algebra 1 video for you all. And as you can see, today's lesson is all about adding and, of course, subtracting polynomials. So this is going to be just about combining like terms of expressions and taking that into higher scale levels with our new chapter all about polynomials. Now, before I get into the lesson, please make sure to hit that subscribe button, turn on post notifications, hit that like button, and leave a comment down below to show your support. It helps us out a lot. So let's dive right into it. We're going to take a look at the first two methods that come to mind when it comes to combining polynomials together, the addition and subtraction. This first half, the second half will be multiplication and division in our next video. But in terms of adding and subtracting, there's two major methods called the horizontal and the vertical methods to combine these polynomials using like terms. Now, the first method is called the vertical method. And as you can see, it's pretty straightforward, just as the name implies. This would be considered the traditional method of adding and subtracting regular numbers, just as you would with your regular numeric values, your natural numbers, essentially. This occurs when you line up the terms in terms of place and degree value. Like, say, for example, if you're adding, let's say, 150 together, correct? You would just line them up in terms of their units, essentially, their digit values. So this would be your ones place, obviously, and then this would be your tens, and then this would be your hundreds, so on and so forth. So you'd line them up, and then you'd merely add them vertically using those singular digits to add up. So in that same manner, that's what you're going to do with the vertical methods. That's how you'd combine your polynomials, your expressions. Now, the other method here, let me just clear this up. The other method would be considered the horizontal method. And the horizontal method is when you would add polynomials side by side. So you just leave them side by side, and you would distribute negatives when subtracting. So in order to do that, obviously, for both of these, you need to convert into your standard form, meaning from preceding degrees, because you have to add like terms together. It just helps you organize. And the horizontal method, you wouldn't be putting them vertically. You just be leaving them side to side and matching like terms together. And this is what I think is the more preferred method. Now you might be thinking vertical method, that's something we're used to. But once you get into larger polynomials, you'll start to realize that the horizontal method will get you quicker and it's easier to use when subtracting. All right, so now let's take a look at adding polynomials. So in terms of adding polynomials, we're going to add the following polynomials together. We're going to combine like terms, essentially. So as you can see here, we have these two polynomials together. And first thing that comes to mind, you might see that they're not in standard form, meaning the degree measures are not from greatest to essentially least in all of these. So let's order them in standard form first. So we have this giant polynomial here. So we're going to order them by degree level from greatest to least. So each term is essentially each set of digits that are multiplied together and they're not added together. So we have 7x to the fifth. Fifth is our highest exponent. So 7x to the fifth stays. Then, of course, we have 25x to the fourth. That's the next one, the preceding one from the preceding one. And then we have 25x to the fourth. And then we're going to add 6x to the third because 5, 4, 3. 3 is our next exponent. So 6x to the third. And then, of course, here we have our variable x, y, and 3. So a constant is always going to be x to the 0 because 3 times x to the 0 is just going to be 3. So in this case, 3 would be last, and x to xy, that's going to have a degree measure of 1, essentially. It's going to be to the first degree. So xy plus 3. And then over on this side, let's do the same thing. So we know that to the fifth is our largest, so 3x to the fifth. We're going to add 13x to the fourth because 4 comes next. And then, of course, negative 6x cubed for 3. And finally, we have plus 4xy because that's just going to be a degree of 1 because x to the first and y to the first. Your variables is just going to be x to the first and y to the first exponent. So now that we've organized this, we can essentially take like terms and add them together. Like terms are essentially of the same variable and exponent. That's what we're looking for here. So if we take a look at term 7x to the fifth, that immediately, you can see that correlates to 3x to the fifth. 25x to the fourth, that's an x to the fourth, and that's going to correlate with 13x to the fourth. Then, of course, 6x cubed, that's x cubed. That correlates with negative 6x cubed, so on and so forth. So now that we've discovered that, we put them in order already, so now we can merely add them together. So the first things that we're going to do is we're going to add together 7x to the fifth, 3x to the fifth. So that merely you're just adding coefficients together, so you're left with 10x to the fifth. Then next, we're going to take 25x to the fourth and 13x to the fourth. When you add them together, you're going to get 38x to the fourth, adding exponents again, because they are like terms. Then we have 6x cubed, circle that. And then we have our negative 6x cubed. If we add those together, that's just going to cancel out. That's going to be a 0, so we don't have to put anything there. Then, of course, we have plus xy and then plus 4xy. Those are of the same like terms, xy, and to the first degree. So that's going to be xy plus 4xy. That's 5xy, because this is merely just one xy. All right, and then lastly, we have this lonely 3 left. Nothing pairs with the other polynomial here, so we're just left with plus 3. And that's going to be our answer. This is why I prefer the horizontal method. With larger polynomials, it does get a little bit easier, and with vertical method, you can, by accidentally, you can create an accidental shift. It can be hard to remember how exactly to line them up because of the length of these terms. So I like the horizontal method, but whatever floats your boat. So now let's take a look at subtracting polynomials. Let's add the following polynomials together, except there is a little bit of a twist. Now, notice how I said add here. The reason why I say add is we're always going to add in horizontal method. However, in this case, this is technically going to be a subtraction. Now, what exactly do I mean by always adding? Well, in vertical method, when you're subtracting numbers like 100 minus 50, you're just going to do subtraction, and then you're going to get your 50 here. However, with horizontal method, what you're going to do first is you're going to want to distribute your negative out so that it ends up to be addition. So you're going to distribute this negative because it's negative essentially times that whole expression. You're going to distribute that negative out. So then you're just adding the opposites. So whatever is negative, you calculate the inverse. When you add the opposite, it's the same thing as subtracting. So let's clear this out. So let's first restructure these in standard form because they're obviously not. They're a little bit obscured. So we're going to start off here, 6x to the fifth. That's our largest exponent. Then any exponents with 4, that's plus 3x to the fourth. Then obviously we have a negative 2x cubed plus y squared, and then plus our constant 3. Then, of course, we're going to subtract that. Excuse me. Then we have negative 12x cubed. Sorry. We have our largest exponent being 10x to the fifth minus 6x to the fourth minus 12x cubed plus 2x. So only 4 terms in this one. Just make that crisper 4. All right. So now that we've calculated that, all we're going to do is distribute our negatives into each and every single one of these terms here. So let's rewrite this here. So 6x to the fifth plus 3x to the fourth minus 2x cubed plus y squared plus 3. And then we're going to add this because we distributed our negative. So that's negative 10x to the fifth, negative 6x to the fourth. So that's double negative. So that's plus 6x to the fourth. Double negative with negative 12x to the fourth. So that's plus 12x cubed. And then we're going to subtract that negative 2x as you distribute that negative there. So it's minus 2x. All right. Now we can just add these together. They're already ordered, in degree order. So we can just add them together. So 6x to the fifth and negative 10x to the fifth. Those add together. And we're left with a negative 4x to the fifth. Then we have 3x to the fourth and 6x to the fourth. That's just 9x to the fourth. 3 plus 6 is 9, so 9x to the fourth. Then negative 2x cubed and 12x cubed. That's just going to be 10x cubed. Then y squared. Obviously here you notice that we actually don't have anything to pair up with our y squared. So we're going to leave y squared here. Because it is the next exponent, essentially it's y squared here. That's your next degree from 3 cubed to 2 squared. And then obviously we're left with a constant and then a variable. So this is going to be the first. This one, 3, is going to be to the 0. Those don't pair up with each other either. They don't pair up with anything else. So we're just left with negative 2x plus 3. And that is our final answer. All right. Well, that'll be all for today's video. I hope you guys enjoyed. This has been the eCoreAcademy e-learning platform. please make sure to like and subscribe, and leave a comment down below. Turn on post notifications. Check out our website at www.eCoreAcademy.org. Email us at eCoreAcademy@gmail.com, and check out all of our socials down in the description box below. I hope you guys enjoyed this video. This has been AJ Raj, and I'll see you guys in the next one. Peace.